Good morning, students. I'm Teacher Betty, continuing with advanced inorganic topics, lesson 5. In lesson 4, we looked at higher boranes, where we looked at their preparation. We highlighted the Watts method. This one treated the diborane iodide with the sodium amalgam to give rise to tetraborane 10 and the other methods of preparation. We looked at the general properties of boranes, where we said they are either gaseous compounds, liquids, or solids. They are electron deficient compounds, and this was confirmed by having higher number of atomic orbitals in a given borane more than the valence electrons. We looked at how to generate a structure of a diborane using the equation of balance. Today, we are going to look at inorganic polymers. Inorganic polymers, these are covalent macromolecules which do not have carbon in their backbone. And examples are oxides and halides, condensed phosphates, and so on. These polymers possess distinctive physical chemical characteristics and unique physical, mechanical, and electrical properties. They are used extensively in areas of engineering and technology. The similarity between inorganic polymers and organic polymer is that they can both be prepared by addition and condensation methods. Classification. Inorganic polymers, the first classification depends on whether the polymer contains the atoms of only one element or different element in its backbone. These polymers can be again classified into two groups. We have the homoatomic polymers. These ones contain the atoms of only one element in their backbone. Examples are phosphorus, sulfur. Sulfur has a tendency to form chains or rings in elemental form. Another one under the first classification is the heteroatomic polymer. This contains the atoms of different elements in their backbone. The second classification is based on the type of reaction which the polymer are being formed. They may be of two types. We have the condensation polymers. These ones are formed by condensation process in which two or more simple molecules of the same substance polymerize to form a condensation polymer. In this process, smaller molecules are eliminated like the water, ammonia, hydrogen, you can name them. Example of condensation polymers: when phosphorus pentachloride is partially hydrolyzed by water, dichlorophosphoric acid is obtained. When this acid is heated, many molecules of this substance get polymerized and give rise to the formation of a condensation polymer. And in this process, hydrogen chloride is eliminated. An illustrative equation is shown below. Phosphorus pentachloride plus little water, you get the acid. Then on heating, small molecules of these get joined together or polymerized together to give rise to the condensation polymer. It's a linear polymer. Another type of the second classification is the additional polymer. These polymers are formed when many simple molecules or monomers combine together to give rise to the additional polymer. An example, we have many molecules of sulfur trioxide which polymerize by addition of small amount of water to give rise to an additional polymer. Another one is sulfur dioxide, which react with the polypropylene in the presence of benzyl peroxide to give the additional polymer. Another type under the second classification is the coordination polymer. These are formed by the addition of saturated molecules to each other, all by a combination of ligands with the metal. These polymers contain chelated metal atoms or ions. An assignment I can leave you with, you can read about types of coordination polymer and also look at their preparation. The third classification is according to the inorganic polymer. According to this one, according to this classification, the inorganic polymers can be classified into the following categories. The first category is the polymer containing two bridging bonds per unit. Those ones are homoatomic, examples, homoatomic sulfur and others. Then the second category is the alternating silicon oxygen polymer. The third one, the alternating phosphorus nitrogen polymer. An example are the phosphonitrolic halide. Those are the ones we are going to look at in the future lessons. Another category is the alternating phosphorus oxygen polymer. An example is the polyphosphate, metaphosphate, and others. The first classification is based on the element which form the inorganic polymer. These ones we have the polymer containing boron, e.g. the borazine, which will be in the second lesson. Polymers containing silicon, polymers containing phosphorus, the polyphosphate and metaphosphate, and the others. Let us look at the general properties of inorganic polymers. Most of the inorganic polymers do not burn, but only soften or melt at higher temperatures, except polymers containing sulfur. Another property, inorganic polymers having a close linked structure with many covalent bonds are generally stiffer and harder than the organic polymers. The next one is, since most of the inorganic polymers are built up by highly polar repeated units, these polymers dissolve only in polar solvents, unlike organic polymers, which dissolve in non-polar solvents. Another property, inorganic polymers are generally less ductile than organic polymers. Another one is the inorganic polymer have structures which are purely crystalline and purely amorphous, while organic polymers have structures which partially crystallize and partly amorphous. Partly crystalline and partly amorphous. Inorganic polymers are generally stronger, harder, and more brittle than the organic polymers. So that has marked lesson 5. Next time we are going to look at polymers containing boron.